Hi dears, today we can see how to find the eigenvalue and eigenvectors for the matrix 2 by 2 matrix. So since this is a 2 by 2 matrix, we can write the characteristic equation is lambda square minus trace of A into lambda plus determinant A is equal to 0. So here lambda square minus trace A means the diagonal value you have to add it, so that 4 plus 2 into lambda plus determinant A is 8 minus 3, which is equal to 0. So that you are getting lambda square minus 6 lambda plus 5 is equal to 0. So the roots here is minus 6, 5. So 1, 5 minus minus. So here lambda minus 1 into lambda minus 5 equal to 0 gives lambda equal to 1 and lambda equal to 5. Let's check how to find the eigenvectors. So here I am going to explain you two methods how to find the eigenvector. So the first method is method 1. Method 1 I am using A minus lambda I into x is equal to 0. So here A is 4 minus, 4, 1, 3, 2. That is our matrix. So I am taking lambda equal to 1. So 4 minus 1. See the matrix here, 4, 1, 3, 2. Yes, 4, 1, 3, 2 minus lambda into x1, x2 is equal to 0, 0. So that 4 minus 1, then 3, 1 into x1, x2 is equal to 0, 0, right? Yeah. So that here 3x1 plus x2 is equal to 0. Again the second 3x1 plus x2 is equal to 0. So here both also equal. So let I am taking x1 is equal to 1. So that this become x2 is equal to minus 3. So lambda 1 eigenvector is x1, x2 which is equal to 1 minus 3. This is the first eigenvector. Let's see the second eigenvector, lambda equal to 5. The same you have to use it. Lambda equal to 5. So that 4 minus 5, 1, 3, 2 minus 5 into x1, x2 is equal to 0, 0. So that here minus 1, 1, 3 minus 3 into x1, x2 is equal to 0, 0. So that minus x1 plus x2 is equal to 0 and 3x1 minus 3x2 is equal to 0. So this gives x1 minus x2 is equal to 0. The both are same. So let I am taking x1 equal to 1. So that this becomes x2 is equal to 1. So that the second eigenvector is x1, x2 which is equal to 1, 1. So the two eigenvectors are, you can see here 1 minus 3 and 1, 1. So this is the first method I am used here. A minus lambda I x is equal to 0. Let's see the second method. Second method is method 2, that is A x is equal to lambda x. So this method. So here A is 4, 1, 3, 2, x1, x2. I am taking lambda is equal to 1. Which is equal to 1 into x1, x2. So 4x1 plus x2 is equal to here x1 and here 3x1 plus 2x2 is equal to x2. So this gives here 3x1 plus x2 is equal to 0 and then 3x1 plus x2 is equal to 0. So that both equations are equal. Let I am taking x1 is equal to 1. So that you are getting any one of this equation, that is x2 is equal to minus 3. So the first eigenvector is 1 minus 3. This only we get for the first method, right? Let's see for lambda equal to 5. So lambda equal to 5, the same I am using ax is equal to lambda x. So a is here 4, 1, 3, 2 and x is x1, x2. Lambda is 5, x1, x2. So that you are getting the value here 4x1 plus x2 is equal to 5x1 and 3x1 plus 2x2 is equal to 5x2. So this gives minus x1 plus x2 is equal to 0 and here minus 3x1 minus 3x2 is equal to 0. This gives x1 minus x2 is equal to 0. So both equations are equal. So let I am taking x1 is equal to 1, so that this become x2 is equal to 1. So the second eigenvector here I am getting as x2 is equal to x1, x2, which is equal to 1, 1. So both answers are equal. Here 1, 1, and here also we are getting 1, 1, and here 1 minus 3, so 1 minus 6. So these are the two methods either you can use for eigenvectors. Hope it helps you. Thank you.